All right, so today's lesson is over the unit circle. Now, we actually did the unit circle last Friday. We did some practice with the unit circle last Friday. And we talked about radians, right? We used the unit circle and marked up some radians. So today we're going to talk about the unit circle in terms of its basis for trigonometry. So let's talk about what is the unit circle. Well, the unit circle has a center that is located at the origin. The center is at the origin, and it has a radius that is equal to 1. The radius is equal to 1, and that's where the name unit, because it's 1 unit, that's where the name unit circle comes from. So from our work with equations of circles, which of the following equations here would represent the equation of the unit circle? Well, first off, I want to tell you, remember that your center is 0, 0, which represents h and k. The radius is 1. That's why it's a unit circle. And the formula or the equation, the standard equation, the standard form is x minus h, the quantity squared, plus y minus k, the quantity squared, equals my radius squared. So if I think about my coordinates, and I plug them in, well, I really have x minus h is 0 squared, which is just x squared. Plus, let's see, y minus 0 is just, the quantity squared is just y squared. And if my radius is 1 squared, that's just 1. And so the equation, x squared plus y squared equals 1. This represents the unit circle, okay? All right. So now we're going to think back to our special right triangles, and we're going to try and produce some measurements for those special right triangles. So remember, this is a unit circle, and what that means is every single time we talk about it, the radius is what is the measure of 1. So this represents the radius of our unit circle. So let's just think about the 45, 45, 90 right triangle, and let's figure out what the side measures are, what those x's are. So this is a 45, 45, 90 special right triangle. And I know that you learned about those in math too. So I'm going to use Pythagorean theorem, right? So I have the legs squared. The sum of the square of the legs equals the square of the hypotenuse. Well, x squared plus x squared is 2x squared, and 1 equals the hypotenuse squared, which is just 1. To get x all by itself, I need to divide both sides by 2, and that leaves me with x squared equals 1/2. Let's see, x squared equals 1/2. Well, I have to unsquare that, right? I have to get x all by itself, so I'm going to take the square root. Remember, when you take the square root of a fraction, you take the square root of the numerator and of the denominator. So x equals, well, let's see, the square root of 1 is 1, and the square root of 2 is some nasty decimal, so we're just going to leave it like that. Now, if I remember correctly, I cannot leave a radical in the denominator. That's nasty, right? So I'm going to multiply by this fancy looking number 1. Now, this is just a special number 1. The square root of 2 over the square root of 2 reduces to 1. So when I multiply by 1, when you multiply any number by 1, I don't change the value of the number. I just change its appearance, right? So 1 times the square root of 2 is the square root of 2. And the square root of 2 times the square root of 2 is 2. So that means that this side has a measure of the square root of 2 over 2. And this side also has a measure of the square root of 2 over 2. These are both the same because both of the sides are the same, right? The legs are the same. So we call these the twins. We call these the twins. All right, now let's look at another special right triangle, the 30, 60, 90 right triangle. So we have this triangle shown to the right, and it says clearly this is half of an equilateral triangle. Well, it wasn't that clear to me until I drew it. I needed to kind of sketch it out. That's how my brain works. I'm kind of got that visual brain, right? So when I sketched this out, I was like, oh my goodness, 30 and 60. Let's see, things I know about an equilateral triangle. Well, all of the angles, all of the interior angles have a measure of 60 degrees, and all of the sides are the same. Okay, very cool. So if all of the sides are the same, and I take that equilateral triangle, right, and I cut it in half, which is what I started with, what is this measure? Well, it's half of this side. Half of 1 is 1/2. And this is my short leg. This is the short leg, okay? So let's figure out this other side of the 30, 60, 90 triangle. Let's figure out the measure of the long leg, because that's what that other side is. I have a short leg and a long leg. Okay, well, we're going to use the Pythagorean theorem. So my short leg, so it says, what is the length of the shorter leg? The length of the shorter leg is 1/2. So I'm going to jump down here to using the Pythagorean theorem, find the longer side. So let's see, I have 1/2 my short leg squared plus my long leg squared equals the hypotenuse, which is 1 squared. So 1/2 times 1/2 is 1/4 plus x squared equals, and 1 squared is 1. So I'm going to subtract 1/4 from both sides. And that gives me x squared equals 1 minus 1/4 is 3/4. I have to take the square root of both sides. Remember, when we take the square root of a fraction, we just break it up. The square root of the numerator, square root of the denominator. So x equals, well, the square root of 3 is some hideous decimal, so we're going to leave it as the square root of 3. But the square root of 4 is a nice integer, 2. So that means that my long leg has a measure of the square root of 3 over 2. So this is how I remember these. And I just kind of say it to myself out loud to remember it. Short leg has a measure of 1/2. Long leg, square root of 3 over 2. Okay, so let's move on to the unit circle. So we're going to think about what we just did in our exercises, right? And we are going to do some manipulating, and we're going to label our unit circle. So I'm going to start with the 45-degree angle, and I'm going to shrink it up so I can draw some triangles off to the side. So I'm going to start with the 45-degree. So that just means that this angle right here is 45, and this is my right angle. So this is the triangle that we're referencing, this triangle right here. So I'm going to re-sketch that over here. I know that my radius is 1. Well, remember that both of these sides are the same, and this is the twins that we talked about. This is the twins. So that means that this is the square root of 2 over 2, and this has a measure of the square root of 2 over 2. Well, that's great because we're identifying the x and the y coordinate of our unit circle. We're identifying the x and the y coordinate. So when I think about x is my horizontal. Well, x is the square root of 2 over 2. And y, well, that's my vertical. And that is also the square root of 2 over 2. Okay? So let's think about identifying all of the angles that have 45 degrees as its reference, meaning this angle right here, right? This is made from a 45-degree angle. 45 degrees would be the reference angle. I also have this angle right here. And I have this angle, right here. So I've identified my 45s. What I want you to think about is what happens when you reflect, right? What happens when you reflect an image across the y-axis? So I'm taking this image right here and I'm reflecting it over this way. Well, just think even better, or easier still, I guess, is think about the value of the coordinates in each quadrant. Like, I know that my x coordinate and my y coordinate are both positive in quadrant 1. And I know that my x coordinate is negative in quadrant 1, but my y is still positive. Sorry, in quadrant 2. I know in quadrant 3, x and y are both negative. And in quadrant 4, x is positive and y is negative. So if this triangle is just being reflected, the numbers don't change, just the sign. So that means that the ordered pair for 135 is negative square root of 2 over 2 and positive square root of 2 over 2. Remember, these are the twins. They go together. Okay? And then the ordered pair for 225 degrees, well, x and y are both negative. So negative square root of 2 over 2 and negative square root of 2 over 2. Because again, these are the twins. They go together. And then 315 degrees, well, x is positive, so the square root of 2 over 2 and negative the square root of 2 over 2. Okay, so I am going to connect these and show you that because the x and the y's measures on each of them, they're twins, right? They're the same. This makes a square. Each side is the square root of 2 over 2 added together. Each side is the same. Okay? So now let's look at our 30-degree angles. So when we have that 30 degree, that means that we are, I'm going to make this a little bit bigger so we can see it. So that means that this angle right here is 30 degrees. This is what I'm talking about. That's my 30-degree angle. Okay. So when I think about that, I'm going to maybe sketch this off to the side. So this is my 30 degree. Here's my right angle. This is my this is my short leg. And I remember that my short leg is 1/2. And this side is my long leg. And I remember that my long leg is the square root of 3 over 2. So when I think about the x and y ordered pair, for the 30-degree angle, I have x is my long leg, the square root of 3 over 2, and y is my short leg, 1/2. Now again, we're going to do the same thing that we did with the other angles, the 45s, and we're going to identify all of the 30-degree angles, or all the angles that have a 30-degree reference angle, right? Because this is 30 degrees, and this one is a 30 degree, and this one is a 30 degree. So thinking about what you did with the 45s, I want you to label the x and y ordered pairs for each one of these angles. I'm going to pause the video for a second. I'm going to pause or freeze my screen. Okay, I'm going to freeze my screen. So you label those and we'll come back. Okay, so hopefully you've unpaused your screen and you see that we have currently labeled all of our 45s and all of our angles that have 30 as a reference angle. I'm going to do the same thing. Notice that this is longer on the horizontal side. It's going to make a rectangle, but the horizontal side is longer than the vertical side because the horizontal, the x coordinate, is bigger than the y coordinate. So first off, just let's look at this and what do you notice? Well, I noticed that all of the twins have a denominator of 2. Actually, all of my measurements have a denominator of 2, but I also noticed that these are my 30-degree angles. All I'm doing is changing the sign as I work around them, right? All I'm doing is changing the sign as I work around the circle, Okay. So now let's look at our 60 degree. And I probably don't even need to draw this out. You're probably at this point able to do this on your own, but I'm going to anyway. So this right here is 60 degrees. I don't know if you can see that arc I drew right there. So I'm going to draw a 60 degree right triangle, 30, 60, 90, right? So this is my 60 degree measure. Well, again, I have a long side and a short side. Remember, the short side is 1/2. The long side is the square root of 3 over 2. So that means my x coordinate is now the short side. So my x coordinate is 1/2. And my y coordinate is the long side, square root of 3 over 2. So again, I'm going to identify all of the angles here that have a reference angle of 60 degrees. Identify all of the ones that have a reference angle of 60 degrees. And so you're going to do just like you did with the 30 degrees. You are going to go through and label the ordered pairs. You're going to name, if you will, the ordered pairs for all of the angles that have a 60 degree reference angle. And then we'll just go back through and do the ones that we didn't talk about at the very beginning, I guess. So anyway, so think about what happens when you move to quadrant 2, quadrant 3, and quadrant 4. What happens to your signs? So again, maybe pause your video and fill out your, label your ordered pairs, and then you can check. Okay. So hopefully you've got them labeled and you've unpaused your video. So I'm going to connect these 60 degree angles again. I'm going to kind of box those in, and I have rectangle. And notice here, my rectangle has a longer vertical. The vertical side is longer than the horizontal, and that's because the vertical side, y, is larger than the horizontal, the x coordinates. So that's kind of how I remember that. I think that box is really a really good visual. So we did not label 0, 90, 180, or 270. And I just think it's kind of important that we do label those. So remember that here, the radius is 1 unit. So right here, this ordered pair, well, x is 1 and y is 0. X is 1 and y is 0. So now let's move up to the 90 degree. Well, the 90 degree angle, that's right here. And again, at this point, x is 0, and my y coordinate is positive 1. Okay, so let's go over to 180 degrees and name the x and the y ordered pair. Well, here x is negative, and it's 1, -1. It's 1 unit. Y is 0. And then for 270, x is 0, and you guessed it, y is -1. Okay, so this is going down 1 unit. There's no horizontal movement, only a vertical. Okay, all right, almost finished. So lastly, we are going to take a look at some angle measures and in degree and in radians, and we are going to give the ordered pair, the coordinate pair. Okay, so it helps me to kind of sketch these out, and this is how I think about them. So we're going negative, and I think about, okay, well, let's see, negative 120, well, that came from a 60 degree and a 60 degree, right? So I went 60 degrees here and 60 degrees here. Those are my references. So my 120 is going to end up right here, negative 120. And when I think about this short leg, That's going to be negative because it's an x coordinate. Well, my short leg is 1/2 and it's negative. And my y coordinate is also negative and it's negative 3, square root of 3, sorry, over 2. Okay, so that's where negative 120 lies. And I draw a picture just like that. So now let's think about 495. So this one was a little tricky. I know that I'm going to make one whole revolution. So starting at 0, I'm going to make one complete circle. That's 360 degrees. So what do I have left? Well, I have 135 degrees left. And I know that that is a 45. So I have a 45. These are the same. This is my twins, right? And another 45. So this is like a representation of the twins. Twins are the same, square root of 2 over 2, square root of 2 over 2, except I'm in quadrant 2. So that means that x is negative. So your ordered pair is negative square root of 2 over square root of 2. All right. So now let's think about our unit circle in terms of radian. So 0 to pi. All right. So remember that the denominator, I don't remember which one of you guys said this, but here's how I think about this. The denominator tells me what I'm dividing, because remember pi is 180 degrees. The denominator tells me what I divided 180 by. So I divided 180 by 3, and that gave me 60. That means that this is 60 degrees. Okay, if there was a 2 on the top of here, that would be 60 times 2 or 120, right? So this is the 60 degree. It's asking me for the ordered pair when x is, or when the reference angle is 60 degrees, or pi over 3. Well, 60 degrees, the ordered pair is my short leg, 1/2, and my long leg, the square root of 3 over 2. Okay. Last one, I know I'm taking up a lot of space and I apologize for that. Last one is also in radians. So I have 0 to 180, which is pi. And I have 3/2 pi. So let's see, this is half of a pi, and this is 3/2 of pi, 3 pi over 2. So when I think about that ordered pair, right, well, I don't have any horizontal movement. I just have, so my horizontal, my left or right movement is 0, and my y is -1, right? So those are the ordered pairs. So I hope that helps. Enjoy your unit circle.